All right. So, number 1, this is once again in standard form for the top equation. So we have two choices. We can rearrange the terms and solve for y so that I can graph that. So that would be like negative 2y equals negative x. Divide both sides by negative 2. And we get y equals positive 1/2 x. That means it has a y-intercept of 0, 0. And goes up 1 over 2 or down 1 and left 2. We're then going to graph the second equation. It has a y-intercept of negative 3, a slope of positive 2. Once you see where they overlap, it is helpful to do a point beyond. So it says to solve. Well, the solution is the point of intersection, and these two graphs intersect at 2, 1. Similarly, in number 2, we're going to solve for y, so we subtract our x, divide by 2. Plot your y-intercept and apply your negative slope. So now my graph is going down. So there's y equals negative 1/2 x plus 2. Similarly here, we're going to solve that equation for y. So you have negative 3y equals negative 2x plus 1. Divide everything by negative 3. A negative divided by a negative becomes a positive 2/3 plus a negative 1/3. Well, that's kind of not the nicest y-intercept. So you could look at the x-intercept, which means plugging in 0 for y, which would give 2x equals 1, which gives x equals 1/2. Still not wonderful, but it's about as good as you're going to get. So you could go through 1/2 and apply your slope of 2/3. So I'm going to go up 2 and over 3. And I see that my graphs intersect at 2, 1. In number 3, we're going to subtract over 2x. So I get y equals negative 2x plus 3. I'm going to plot my y-intercept, go down my negative slope. Negative 9/2 is like negative 4.5. But if you think about x equaling 1, that would be like 1/2 times 1 minus 9/2. So 1/2 minus 9/2 would give negative 8/2, which is negative 4. So I could plot the point 1 negative 4 as opposed to negative 9/2. And then apply my up 1 over 2. And I see that my point of intersection is 3, negative 3. Yeah, hon. Your what? Like the 1 negative 4? So technically you can plug any point into a function and get a point on the graph. So when we start a graph at the y-intercept, technically what we are doing every single time is plugging in x equals 0. So like when x equals 0, in the case of this problem here, you get y equals 1/2 times 0 minus 9/2. So I get y equals negative 9/2, which is the same as negative 4.5. But that's not a very nice point to start my graph at. So what I did was say, okay, instead of starting at 0, negative 4.5, I'm going to plug in the number 1. When I plug in the number 1, I get negative 4. So instead of starting my graph at 0, negative 4.5, which is like here, I started my graph at 1, negative 4, because if I can start my graph at a perfect point, then I can apply my slope from that point. So I just tried to make my starting point nicer. In number 4, my starting points are nice. You have y equals x plus 3. So like you start when x equals 0, which is along this axis here, and you plot your y-intercept, which is positive 3, and then you apply your slope. So technically, every time we're starting a graph, we're starting our graph when x equals 0. When x isn't nice at 0, we start it somewhere new. But if I'd have plugged in negative 1, I'd have gotten positive 2, and could have started my graph here and applied the slope. Technically, all of these points on the graph are points I could have started it at. Y equals 1 is a horizontal line. The slope at y equals 1 is 0, so it goes straight across because there's no x value. So my point of intersection is where these two graphs meet. So they meet when x is negative 2 and y is 1. In 5, subtract 2x, divide by negative 1, plot your y-intercept, apply your slope, do the same for the next equation. Negative 2 divided by 2 is negative 1. Apply your y-intercept, apply your slope, and we see that the points intersect at 2, negative 2. In 6, same idea, solve for y. Plot your y-intercept if it's nice. Connect your 2 points. Graph your second equation. And once again, this y equation is not very nice because it's a 2/3. So maybe we look to start the graph at the x-intercept instead of the y-intercept. So we set y equal to 0 and solve for x. So when y is 0, x is negative 2. So if I start my graph at negative 2, 0, and then apply my slope of positive 1/3, it will give me a direct intersection at 1, 1, which is my solution. So you have the remainder of class time to do the rest of this handout, which is 4 questions, and then the skills practice on the front. That's due tomorrow, and it's double homework points because it's half of class time plus the homework. So it's 8 points instead of 4. So yes, Jack, that means I would highly suggest doing it.